A warm greetings to all present here for this video presentation. So in this session now we are going to see about the topic which is based on additive manufacturing. That means using the powder based systems. Powder based additive manufacturing system. In previous session you all learned a lot and also gained some knowledge about the AM process and how it works, then what about the process chains, etc. What are the things deals on it. So in the system now we are going to categorize into three major based techniques. So the short introduction that we want to see about the AM technologies is nothing but, the first one is nothing but a liquid based. I think you all get some knowledge about the stereolithography. It's nothing but the resin based is a major role undertaken place. Then next one will be the solid based. In the solid based we have two major techniques is nothing but fused deposition modeling and also sheet stacking technologies. Let me sheet lamination method is there, is called as LOM. This one we are called as FTM. This FTM is probably we are using fully based on this filament score. Then stereolithography we are considering based on the resin. So now we are going to see about the powder based techniques, this powder based system. In this we are having a lot of techniques that we can introduce in this powder based. So mainly we are going to see about the selective laser sintering process, and then the fifth one is nothing but selective laser melting process. So we are going to see about the difference between the sintering and also melting in the upcoming slides based on the videos, explanations, etc. Let's start the session. Selective laser sintering process is called as SEL. A warm greetings to all present here for this video presentation. So in this session now we are going to see about the topic which is based on additive manufacturing. That means using the powder based systems. Powder based additive manufacturing system. In previous session you all learned a lot and also gained some knowledge about the AM process and how it works, then what about the process chains, etc. What are the things deals on it. So in the system now we are going to categorize into three major based techniques. So the short introduction that we want to see about the AM technologies is nothing but, the first one is nothing but a liquid based. I think you all get some knowledge about the stereolithography. It's nothing but the resin based is a major role undertaken place. Then next one will be the solid based. In the solid based we have two major techniques is nothing but fused deposition modeling and also sheet stacking technologies. Let me sheet lamination method is there, is called as LOM. This one we are called as FTM. This FTM is probably we are using fully based on this filament score. Then stereolithography we are considering based on the resin. So now we are going to see about the powder based techniques, this powder based system. In this we are having a lot of techniques that we can introduce in this powder based. So mainly we are going to see about the selective laser sintering process, and then the fifth one is nothing but selective laser melting process. So we are going to see about the difference between the sintering and also melting in the upcoming slides based on the videos, explanations, etc. Let's start the session. Selective laser sintering process is called as SEL. So first of all we are going to see about the manufacturing techniques of the selective laser sintering process. So what are they? Yes, it is patented in the year of 1989 and which is made up of the plastics powder, and also we are going to use this elastomer. The elastomer is also called as somas powder, and the sample which has been built by layer with a uniform thickness. So about the uniform thickness we are going to discuss later. Then there is no milling steps are required for this. That means we are not worrying about the supporting structures for this particular techniques. then the file type, which is called as .stl. So what is the full form for this STL means? It's standard tessellation or triangulation language. Here they are considering as triangle. It's triangulation or tessellation language. So STL is nothing but a file format which is going to convert from one file to another file. That means the CAD model which has been coded into this particular system or through by the software. So through by that we have to convert from the CAD into this STL format. So if you're going to convert into the STL format only, we can able to make the physical components through by this AM technology. Then the finished sample goes for 12 to 24 hours. That means we're going to wait for 1 day, and then we can pull out of the powder. Then we can able to take out that particular physical finished component. Now we are going to see about the process chain of the selective sintering process. This is very important to know about the details. That means first one is nothing but the set of data, then second one will be the process parameter, then third one will be the material. At last we are coming to the final product. So we are going to segregate this into the stages. So set of area, that means a set of data that we can able to consider as a one stage. The second stage we are considering as a material and also the process parameters. So through the stage 2 only we can able to complete this process. That means the product capabilities that we can able to identify. So let's begin able to see about this particular model, which is based on the lion. That means which one is made through by the CAD software. Then after that we have to convert this into a slicing procedure. So how we have to convert means by using the STL format. So CAD format which is converted to a slicing procedure means layer by layer format through by this STL file. So in the set of data we don't know about this data volume, that means how the space which is going to occupy. Then what about the format, whether it is converted into this particular stages or not. Then after that we have to identify the defects that we have to identify in this particular stage itself to continually progress. We can able to complete smoothly our particular physical product. So for that purpose the defects that we have to identify in this stage itself. The next one will be the second stage. Yes, mainly we have to focus on the material. What type of material that we are going to use, that is very important indeed, because the material we can consider as a brittle type or a ductile type. We can able to consider the hard material or a soft material. So based on the applications we have to choose that materials. So in this materials, what are the properties that we need to consider means, for the first one is nothing but we need to consider means the particles size distribution. So purely based on the material that we are going to choose, we can able to identify this size, we can able to identify this size distribution, and also what about the porosity of this particular material, that also we can able to answer for this. Then what about the melting temperature of this particular material. So these are the parameters we need to identify after the conclusion of this material. So materials means we can use nylon material, or we can use the aluminum, or else we can use the metals. Lot of type metals are used in this particular techniques. So next we'll move on to this process parameters. Without the process parameters we can't be able to do the working principle of any techniques systems. So through by the process parameters we need to know about the laser, what about the laser source, what gases that we have to use, and what about this powder deposition. Powder deposition means we need to identify on each and every layers how much deposition which has been taken place, or we are going to identify we need to get that particular complete components of this powder depositions. Then what about the temperature, then what about the scanning speed, that means the building speed in meter second or through by the second that we have to identify. After the completion of this process parameter and also material which has been taken place, then the final product we can able to come to the conclusions. So after we have to make this final product, after the completion of the post processing, next we'll move on to this product capabilities. This product capabilities, whether this particular component is having the mechanical strength or not, or adhesive forces which is constructed by the product or not. and what about the roughness, and also what about the heat conductivity. So these four factors are very important after identify the particular final product, final complete component. So these product capabilities that we can identify using the testing machine and testing machines. Through by numerically we can identify through using the FEA or FEM, which is called as finite element analysis, or we can able to use software to identify this properties. Next we will move on to this image. Now you can able to see the full view of this representative belongs to the selective laser sintering process. So this one is heated and also sealed chamber. Now here we can able to see about a lot of elements which is related to this SLS system. So first one is nothing but a laser. Next we are considering as a scanning systems, then the rollers, then the working part. Then this one is belonging to the cylinders, and also the fabrication bed which has been made up of in the intermediate stage. Then in this left side we are having the powder supply bed, on the right side also we are having the another powder supply bed. So first of all, what is laser unit? It's nothing but a very high powered pulse laser which is used to fuse the particles of the powder material. That means the laser which is used as CO2. The next one will be the building platforms. This one is also builder platforms. So through by builder platforms only we are considering as a cylinder, which is where the part which is going to build. So for the purpose only we are using this. Then the powder magazines. The powder magazines is nothing but the SLS machine has the two major powder magazines on either sides of this fabrication area. The next will be the roller. The roller's function is nothing but which is used to transfer the powder from one magazine to this builder platforms with another layer of this particular thicknesses. Yeah. Next one will be the scanning systems. The scanning system is nothing but the heat from the laser beam which has been steered into the scanning systems to center into the powders together. At last is nothing but the control system, because all the components which has been controlled by this computer systems. So that also we have to consider as one of the elements. Next we'll move on to this picture. So easily you can able to recognize this based on the picture 1, picture 2 and also picture 3. Picture 1, which is deals with the powder layering, which is give an explanation about the role of how it's going to move and what about this working area and where it is going to consider. And the second one is just based on the laser sintering. This laser sintering picture is purely based on explanation about the laser source where we have placed and which is just hit with this mirror and which has been reflected into this particular work area. So this kind of work is going on in this second picture. The third picture is again repeated as the first picture is nothing but that means the layer which is comes to the original position. So when the layer moves from left to the right, the one layer thickness will gets completed and also which has been bonded with the previous layer. That after that, if the roller which moves to the original position means we can able to complete the one more layer of the thickness and that also which is bonded with the another previous layer. SLS process, it can be explained in the 3 stages. That means first one is nothing but a pre-processing, then the intermediate stage is nothing but a processing, then third stage is nothing but a post-processing. The pre-processing is nothing but the SLS process which is began with the 3D CAD software, basically 3D CAD files with a particular part. That part which is going to first converted into a STL file, then the data which is going to slide horizontally into the thin layers of the cross section on the z-axis with the thickness between this, how we are going to consider means 0.0 mm to this 0.1 mm. So that is a uniform thickness that we have to consider, after which has been formatted into the particular SLS data build platforms. Yeah, the next one will be the processing. The processing is nothing but the working principle. Here only the powder which is going to feed it into one edge and also the laser source which is going to work the progression which has been taken place in the processing. So processing is nothing but the working principle that we want to make a final product. Then at last will be the post-processing. What does it mean for post-processing? Means it's nothing but after the completion of this processing work, again we have come to the curing process and also finishing process, cleaning process, etc. Just we are going to remove the excess powder. Then after that we can able to take that particular final product, whether it is suitable means we can get it into the market. Now we want to see about the step-by-step procedure for this SLS. It's nothing but we already explained about this. This is based on the intermediate stage technical process, means the working principle. So what this means, the 2D elements of this laser scan vectors which has been designed for each layer that has been made up of into the 3D objects. The next one will be the layer of the powder which is deposited into this building platform, and after that the powder which is going to flatten by using the rollers. Then simultaneously the laser beam which is selectively sinters, or we want to consider some melting. So we want to consider sintering process. Also we want to consider this SLM process, that is called as laser sintering melting process. So this one is deposited into the powder layers. The powder bed surfaces which has been lowered by the height of one layer thickness. So each one layer is getting ready means what will happen means the powder bed surface will get lower and lower. That means the process is getting ready to make that particular assembled component. The lot of part materials that we are going to make by layer, which is going to merge with us, which is going to bond it with us, the previous layer means what will happen means the assembled part that we are able to collect. So that is the last point that we have mentioned. There is a 3D object has been constructed and the excess powder which has been recycled, which has been used for to make the another objects. Okay, now we are going to see a video which is based on the new method of manufacturing using the powder bed additive manufacturing with the selective laser melting process. This one is based on SLVM. So clearly we are able to see this video. After completion of this video, just we will have questions, questionnaire sessions. We can able to answer ourselves. So let's watch this video. Okay, so what did you understand in this video? Here we are having a few questions that you can ask by yourself after you are seeing this video. It's nothing but what methodology which is used in this process. I think you all know it is nothing but a selective laser melting based process only that we are seeing. So after that is taken, that final product is easily able to identify that because that is based on the metal based component only, it's get it ready. So it's always which is placed on this SLM process is nothing but a methodology. And the second one is nothing but, do you think it's the process is a time saving and also conservative? It's just a question mark. So whatever the answer being unable to consider and also discuss in the upcoming sessions that we are going to meet again. Yeah. Then this is the powder. This is the powder used being recycled in this process. Then at last will be what kind of components, that means the products are manufactured by using this powder based AM technology. So these are the major main questions that we are going to ask. These are fundamental questions based on this video. Now we will come to the comparison between this SLS and also SLM. We are also seeing the video which is based on this SLM is nothing but selective laser melting process. So what is the difference in this means? The both are considering as a powder bed fusion techniques only. See, but what is the major difference means is nothing but the materials. If we are going to consider the polymers means it's nothing but a SLS process. If you want to use the metal base means just we are considering as one of the type is nothing but a SLM. That is selective laser melting process. That is the major difference between this SLS and then SLM. So the same slide, that means what is the difference between the selective laser sintering and also selective laser melting. The truth is nothing but a very similar process. That means the same chains that we are going to use, that means the process chains. But what is the difference means in the material that they are going to use. Which material that we are going to choose, whether we are going to choose the SLS method, material, or we are going to use the SLM materials that we will choose. If you want to use this polymer means just we are going to go with this SLS. If you want to use the metal type product, if you need means based on the application wise, we can go with this multi. That means the pulverized powders which is needs of fine grains, also thermoplastic properties, so that it becomes viscous, flows and solidifies very quickly. So what are the uses of materials that we are going to use in this SLS powder based in manufacturing? So this first one is nothing but a nylon, then glass filled nylon, and also somas, which is also called as elastomer. The polycarbonate. The polycarbonate is widely used because it is durable, at the same time it is heat resistance. Then ceramic, means true form, and also sand forms. At last we are going to see about the metals based, that means a rapid steel and also the copper poly combined. So based on these materials, we have come to this conclusion of this process parameters. That means overall accuracy of about 1%, then the layer thickness of 0.1 mm, this is the maximum they are mentioned here. Then the scanning speed is up to 1 meter per second. At last will be the volume, which is going to operate up to 350 mm, which has been cubed. This next slide we want to see one video which is based on a flexible material. That means the powder-based nylon product which has been manufactured in that particular video. So let's watch. Designed product which is making through using the 3D CAD software with the proper dimensions. Then it is converted into a STL format, and then the data which is going to sliced into the horizontally into the thin layers of the cross sections, and also just formatted into the SLS mission data. After the completion of this, now we are coming to this processing unit. That means a thin layer of the heat powdered material which is applied into the fabricated platform, that is the building platform, by using the rollers. Simultaneously, we can able to see that the laser scan, which is selected area of this particular working area, which is bonded into the previous layers. So the process gets continues again and again until the entire component gets printed. After the completion of this, we'll come to the post processing. So which is going to left into the cooling process in this machine before which is going to remove. It is very simple to which is very simple to engage in this post processing. That means just we want to removing the excess powders. That's it. Um, so after the completion of this removal of this powders by using the jet machine process, take out of this particular finished components. Now easily we cannot observe what kind of material is this because this was flexible. So this video is purely based on the powder material is nothing but nylon. So the powder based nylon finished component is getting ready. So that's the input codes just that we are going to code it as our design product, which is converts into a physical product by using the EAM technology. That means powder based EAM technology.
Okay, now we'll see the advantages and also the disadvantages. So just we have selected three advantages points and also the three disadvantages because these are the major aspects in disadvantages and also disadvantages. So we start. In disadvantages, the first point is nothing but a good part stability. It is parts which has been created within the precision control environment. The second one is nothing but the wide range of this processing materials. They are wide range. That means which has been included nylon, then polycarbonates, metals, and also ceramics which has been available. So to provide flexibility and also wide scope of this functional applications. At last will be the no part um, supports are required. It means we are not worrying about supporting structures. So that means the system does not require any CAD to develop the supporting structures. So we are not wasting any time for making that supporting structures, building and also the removal. So that's the advantages. Next we'll move on to the disadvantages. It's nothing but the large physical size of the unit. Yes, of course, the system is required a real large space to housing unit. So second will be the high power consumption. Yes, of course, the high power consumption is due to the high voltage of the laser which is required to sinter the powder particles together for the purpose. So last will be the poor surface finish. Yes, of course, when compared to the liquid based and also solid based. In this powder base will be the poor surface finish. That means relatively large particles are sized of this powder which is going to be used. So this is the major disadvantages. Let's see the applications. That means first one is about the concept models. And this concept models means what means? It's nothing but the physical representations of the design which is used to review the design ideas, forms and as well as styles. Then the functional models and also working prototypes. Yes, which is used for testing purpose. The polycarbonate, yes, which one is ideal suited for the design which has been for the thin walls and also for the fine features. At last will be the metal tools. This one which is used for the direct rapid prototyping of the tools to make it up the mold and also for the short production runs. So that's the explanation gets over. So we can see the pictures. These are the applications by using the powder based sintering processes. This first two is nothing but a functional process, or maybe we can use for the conceptual ideas. This last one is nothing but an artificial kit that has been made to the particular one of the human person, which has been fixed in their leg. So what kind of materials that we are using to make this? It's nothing but the powder based only they are using to uh, to get this particular shape. This one is called as an artificial kit, and this one is called as prostatics. Yeah, the technical name is called the prostatics, which is also prosthesis. So the selective laser sintering process is the powder based. How it is related to then this medical field. See, before going to this medical field, we need to know about this. What is implant and what is prosthesis and also prostatics. Prosthesis and also prostatics are same. So what is the meaning for this implantation? We all heard about heart implantations. So like that, what is the meaning for this implant? An implant is a medical device which is made to replace or repair the body parts. which is going to help the patients recovering from the tumor removals or accidents, etc. Then what is going for prostatic prosthesis is nothing but an artificial kit and this artificial substitute or replacement of the part of the body by which of tooth or eye, the facial bones, the hip, knee or another joints, and also legs and arm, etc. So prostatic is the design for functional use or for cosmetics reasons or for the both purposes. Now we'll see about the development cycles of this medical implantations using this AM technology. The first stage is nothing but the needs. What are the needs that we want to identify and what are the objectives? The second stage is what comes the designs basis of this CT scan or CMRI scan. After identify the defects, then we move to the stage 3 is nothing but numerical analysis that we have to do by this finite element analysis. Next one will be the medical applications of additive manufacturing. So we can use it for the operation plannings, the surgical procedures that we have to tell to the particular patients, then surgical rehearsals for this also we can use as some applications. Then for the finding purpose, then prosthetic designs for lungs and also for bone transplants, and the plastic model that we can make for this patient mouths, also prosthesis sockets. Sockets means nothing but a joint or nothing but a link which is going to make. Then will be the human tissues. At last will be the artificial blood vessels. So these are the major medical applications of additive manufacturing. Now we'll come to this one of the case study. Actually, we only see about the two case studies. Because the first one is nothing but the production of hip implantation by using the additive technology. So you can able to see left side picture and also the right side picture. So what they are mentioned in the left side picture, just see this. It's nothing but a total hip replacement. It means we are making some artificial kit here. So this is the original view on it. So in this they are mentioning if the bone has been created, some sort of a growth area that has been mentioned and shared in this below area. So let me see the brief explanation about this case study. That means the primary bone tumor, that means cancer, is lying directly on this bone. This is a very severe illness. So how come, which is how we are going to overcome this? So this was the case with 15-year-old person from the country Croatia. So what is important is not to match that into the fit of this particular hip bone, this joints. So they were all very confused. Then at last we come to the conclusion that what is the solution that we have made means in the AM process which has been created the artificial bone parts. That means by using the powdered material which has been hardened with the lasers, within the week the component has been produced with the AI machine using the stable light titanium alloy. Titanium alloy is the material which has been placed as in a prosthetic kit. So it has been cleaned and also fulfilled the highest medical requirements, and also it has been arrived to the particular country, that is Croatia, within the impressively short time. Then what is the result? The first time the team of the doctors completely removed all the parts affected by cancer, and then the new artificial hip has been inserted, completed with the integrated joints. You can able to see this, the integrated joints. So a lot of joints being able to link with this, with the node points and also with the particular sectors. So what was happening was this precision and also lightweight implant which has been fulfilled all the medical requirements and also the foundation was laid for the patient successful recovery. So based on this, the result has been shown as nothing but the importance of additive manufacturing in the medical sector. The second case, this one also made up of titanium. This is the mandibular. This mandibular implant for the patient. So the disease has been started in this particular jaw. So they remove the total part. Then after that they get this artificial, that means a prosthetic kit here. So in this, actually, what is the solution that they got? It means the surgery has been deemed with successfully with no negative reported complications. So after 6 months, that means post operations, so they didn't get any sort of negative feedback. So they come to the conclusion that the particular team is working now looking to use this additive manufacturing technology in the further growth tactics. Now I am going to end with this session. Now we are going to see one last video presentation, which is based on the medical field, how the additive manufacturing heights, in which height now we are, the world is standing based on additive manufacturing in the medical sector. Let's watch this.
This is the first time that the whole cellular heart with blood vessel is printed. And another major breakthrough is that it is printed from the materials of the patient itself. The next stage is to mature these hearts in the lab for at least a month to help the cells or teach them how to interact with each other, how to provide electrical signal and to have a synchronous contraction or pumping ability of the heart. In a year or two we hope to take these hearts and transplant them in rats or rabbits.
Thank you all for watching this particular session. First of all, thanks to all for your patience till now who all watched this particular slide actually. So I hope you all understand the concept of AM technologies and also the different types and also how it's functioning, how the step-by-step procedure has been taking place like that. And finally, we'll come to the conclusion how the AM technology which relates to medical sectors also. Okay, thank you. Thanks a lot.